Hi. Today we will be recapping Bronsted Lowry acids and bases. I want you to watch the video I made on pH and pH scale in table M. I'll show you, I just posted that. And for homework I want you to finish up the Bronsted Lowry sheet. I just uploaded it. It's the one I'm going to show you here. Remember that the pH of common acids and bases is due tomorrow at noon. That's Tuesday at noon. Lauren asked if we're using the one that was handed out or the one that had the questions on it. It's the one with the questions on it, so I will post that as well. I'm pretty sure you got both of them, but to make sure I will post that one as well. And we'll get to that here in a second. So let's look at the Bronsted Lowry first. Just a reminder, Bronsted Lowry is a different theory about acids, and it's more general. In Arrhenius acids are those that have a hydrogen ion that they give away. So an example would be hydrochloric acid. Hydrochloric acid, when it's mixed with water, will lose this hydrogen, and then it becomes hydrogen ion, and then chloride ion. Remember, this is not a dissociation, it is an ionization, because that hydrogen is going to add with water to form H3O+, and that's called the hydronium ion. Arrhenius bases are those that give off hydroxide, OH-. So this is a different idea here, Bronsted Lowry. We did get the notes in a different video, and I also have posted all the notes. So essentially, you have a pairing here. In Bronsted Lowry theory, we have an acid, and the acid is identified as the one that gives the hydrogen ion up. Remember that a hydrogen ion is also technically a proton. So the words that they use there are essentially, if it's a proton donor, it's an acid, and if it's a proton acceptor, it is a base. So in this case, we have HCl, and it contributes this hydrogen to the water. How can I tell? Because look what happens to the water. The water becomes H3O. And I know that the acid has given up the hydrogen as well because it becomes chloride ion. Okay, so the acid is the one that gives the proton, or the H+. The base is the one that accepts the hydrogen ion. So we've got an acid and we've got a base, and we always link them with the thing that it becomes. So the acid is going to be linked with its conjugate base, and the base is linked with its conjugate acid. Now what does that mean? Again, remember, that arrow indicates that it is a reversible reaction. That means it can go in this direction. So if it were to go in this direction, what would be the acid going from right to left? You've got the H3O+ and the Cl-. So what happens if we go from right to left? The H3O+ becomes water by losing this hydrogen ion. And where does that hydrogen ion go? It combines with the chloride ion, and then the chloride ion becomes the hydrochloric acid. So that's why we call it an acid base in one direction, conjugate acid, conjugate base in the other direction. Okay, so let's take a look at this sheet. I've uploaded it, and I think you already have it in the packet before we left. So all you have to do is identify the acid-base pairs in these reactions. Okay, normally, don't let this throw you off, normally we've learned that OH at the end indicates a base. But if you were to look this up in table L, I believe, table L is the one that shows you the different acids. It could be M, but I think it's L. Let's check actually. My fault, it's table K. Table K tells you acids, and table L will give you common bases. So, in this case, we have CH3COOH. Sometimes you'll see the H in front of this. It makes it a little bit easier to identify it as an acid. But this is acetic acid, and this, you should know by now, is ammonia. Remember, this arrow indicates, the double-headed arrow indicates it's a reversible reaction. So what's going to happen here? We're going to have the acetic acid contribute its hydrogen to ammonia. And how can I tell? Look, this becomes that. And with this negative ion here, it must have lost something, and you can tell just by looking at it that it's lost the hydrogen. So this is the acid, and this must therefore be the base. So what does this become? This acetic acid becomes the acetate ion. So I can link them that way. Since this is the acid, this is what we call its conjugate base. Ammonia becomes NH4 by picking up the hydrogen from the acetic acid. So this base becomes NH4+. And because of that, the ammonium ion is the conjugate acid. So let's think of it this way. If these two combine to form these, if we're going from right to left, this will accept the hydrogen, and if it's an acceptor, it's a base, and this will donate the proton or the hydrogen ion to this, and a proton donor is called a conjugate acid or just an acid. Okay? Let's do one more. Water and water. H3O, hydronium ion, and OH minus. That's hydroxide ion. It doesn't matter which one you pick. You could do this, and then this. So if we link these two, what's happened to this one? It has lost its hydrogen. It has donated its hydrogen. If it donates a hydrogen, it is an acid. If this becomes this, it must have picked up or accepted a hydrogen, making this a base. The base is always linked with its conjugate acid, and the acid is always linked with its conjugate base. I'm hoping that's not too bad. One more. This is cyanic acid, cyanide, hydrogen cyanide, and you can see that the H plus is given off, and then it's by itself here. So this is the acid. It's linked with its conjugate base. Hydroxide ion takes that hydrogen and we could link it with, so this is the base because it's accepting the hydrogen, and this is the conjugate acid because if we go from right to left, this will accept the hydrogen ion, and this will donate the hydrogen ion to become OH minus. All right, finish that up for your homework tonight, post it. Watch the video I made. That. Reminder that the pH of common acids and bases, I already mentioned that. And lastly, if the link isn't working to the video, I just tried it this morning. So here's the video. It wasn't loading before, so I'm going to copy the link in case the error comes up, and it's probably going to error up. I'm not sure why. Okay? So if that happens, make sure you copy the link first, then go here, paste it in, and there's the video. Okay? All right. I will see you tomorrow. I'm going to also load up a quiz that will be due on Wednesday. Quiz will be due on Wednesday, and then we'll be done, and then I'm sending a test home tomorrow. It's all, look it up. So we should do pretty well on that. And then I will have that due most likely on Friday. You will also get a packet tomorrow on the next unit. It's a thick one, but don't get freaked out about it. It's all about organic chemistry, and I will be doing daily videos on those as well. Okay? I'm probably going to set up also a Zoom. I'm not sure how to do that yet, but we should listen to each other's voices, and if you have any questions and such. All right, see you tomorrow.